Today we're going to try and determine whether that the sequence 2 plus n cubed over 1 plus 2n cubed is convergent or divergent. And if it's convergent, then we're going to be trying to find its limit. Now this means that if we can find the limit and the limit exists, then the sequence is going to be convergent. Now right off the bat you could start plugging in numbers for n equals 1, n equals 2, n equals 3, n equals 4, and you could keep going. If you plug in n equals 1, you're going to get 3 over 3. If you plug in n equals 2, you're going to end up getting 10 over 17. 3, you're going to get 29/55. And 4, you're going to get 22/43. And so on. Now, that's not telling us anything really that special right now. So what we can do is we can take L'Hopital's rule and take the derivative of the top, which is going to be n, or 3n squared over 6n squared. And that still doesn't give us anything super nice. So we can keep taking L'Hopital's rule and take the derivative of the top and the derivative of the bottom separately. Now you're going to get 6n over 12n. You could do L'Hopital's rule one more time, but we can see that the n's cancel out and that the limit as n goes to infinity of 6n over 12n is just going to give us infinity over infinity. But when you take L'Hopital's rule, you're going to get limit as n goes to infinity of 6 over 12, which is equal to 1/2. Meaning that the limit exists, meaning that the original sequence must converge. So we have a sub n equals 2 plus n cubed over 1 plus 2n cubed converges to 1/2. Now you can see this if you start plugging in those numbers and looking at what the fractions actually are. This is going to be 1, this is going to be about 0.588, this is going to be about 0.527, and this last is going to be by 0.511, and it's going to keep getting closer and closer to 1/2.